Okay, so we have LeetCode problem number 700. Search in a binary search tree. You are given the root of a binary search tree, BST, and an integer val. Find the node in the BST that the node's value equals val, and return the subtree rooted with that node. If such a node does not exist, return null. Okay, so let's go to the example. We have our tree, 4, 2 children, 2 and 7. 2 has children, 1 and 3. And then our value is 2. So we need to find the 2 and then find its children, is what I'm presuming. So the second question, we have 4 children, 2 and 7. 2's children are 1 and 3. The value is 5, and we'll return an empty array because there's no 5 in the tree. Okay. So this is okay. So we're just looking for a value and then trying to return its children. So we can look through, we can probably go through the tree. So what should we do? Should we go through, okay, let's read some descriptions, or discussions, sorry. A bad description is to say return the node, not the whole subtree. But it is returning the node. Okay. The question is a binary search, not for trees. Recursively. Return the node. Okay, let's not do it by best, newest. BST main conditions must include. Okay, the discussions aren't really helpful. So what do we need? We need a way to track how we are, where we are in our tree. Okay, so let's do, we can do something like this. Var current node is equal to root. And then we probably, we need a way to loop. So we need to loop while our root is not null. Okay, so we need to check if root is null. Okay, so we can do something like this. While let node equal current. So this would make it so that we'll loop it till nil, current becomes nil. So when current becomes nil, we know the value doesn't exist. So the first thing is Let's go back to the question. Find a node and the value that, okay. So when node is equal to val, we want to return the node. So that means we found where we need to be. Okay. So if our node value is equal to the val that we sent in, we can return our node. So we know node will be, and then we need to check which way we want to go. And then, okay, so we can do this, return, we know we're gonna return current. So we're gonna redo our returns here in our loop. So if it comes out of the loop, we wanna return a nil. That means that we didn't find a value at all. Okay. So we want to compare probably our value next to see which way we're gonna go. So we can do if val is less than our node dot val. So this is if it's equal. So if it's less than, then we're going to our, let's go to our, if our less than, so we'll go to our left. And then we can just do it else. And then that should be it. That's simple. So if we get to our, if we find our target, then we just return the entire subtree. So if the target is smaller, we're moving to the left. If it's bigger, we're moving to the right. And then if we don't find anything in our while loop, that means the value doesn't exist. Okay. So yeah, this is better than, so our DFSs, we were doing recursion, but this is more like a error. Definitely not recursion, but I feel like this is gonna be better. Okay, so let's run it and see. Right. And then this is perfect. Okay, let us submit it. Very nice. Now let's look at some solutions. Very simple. Okay, so search BTS. They're doing a guard let. Make sure there's a value. If there's not, no. If our value is value, return the node, or they're returning a root. Okay, so this is a recursion. So they're calling with the left and then calling with the right with the vowels. Oh, this is a very good one as well. Yeah, I wrote off recursive. So this one's checking the root. Okay, so this is using a second function, also using recursion. Okay, so maybe recursion is the way to go. Okay, this is using a while loop, so it's probably going to be similar. Okay, this is using a queue. Shows BFSs that we use queues, DFSs we were using recursion. Oh man. You just use a queue to cache the tree nodes, but we also need to use the advantage of a binary tree and check if the value is greater or lower than before we append to save some runtime. But it also works without this check, just slower. All of these are good. So yeah, this is using recursion. Okay, not bad. This was an easy question. So this was LeetCode problem 700, search in a binary search tree.